The implementation of DSSS at radio frequencies with a high transmission rate costs less than implementing FHSS. At a given transmitting power, FHSS offers higher power spectral density than DSSS. The invention of wireless communication has brought about opportunities that we previously thought impossible. People living on two different continents are now able to communicate instantaneously through wireless communication. However, wireless communication systems are still far from perfect. Over long distances, the quality of wireless communication can be challenged by atmospheric conditions, crosstalk, electromagnetic interference, and noise. To limit these issues, spread spectrum techniques can be used for signal transmission in wireless communication systems. There are two types of spread spectrum techniques: the frequency hopping spread spectrum (FHSS) technique and the direct sequence spread spectrum (DSSS) technique. FHSS and DSSS both have their advantages, and choosing between one or the other will depend on the type of application for which the technique will be used. The frequency hopping spread spectrum (FHSS) technique. The spread spectrum technique, in which the carrier frequency is changed according to the pseudorandom noise or sequence injected, is called the frequency hopping spread spectrum (FHSS) technique. The pseudorandom sequence is only available with the transmitter and receiver. The signal transmitted is injected with noise, increasing the bandwidth of the original information. At the receiving end, the pseudorandom sequence is removed to retrieve the original information. The FHSS technique prevents the loss of data and limits noise, crosstalk, and electromagnetic interference, preserving the signal integrity and reliability of communications. According to the frequency at which the RF frequency varies in signal communications, the FHSS technique is classified into either slow frequency hopping or fast frequency hopping. In fast frequency hopping, the hopping is carried out at a faster rate than the information bit rate. When the frequency hopping rate is less than the message bit rate, the spread spectrum technique is called slow frequency hopping. The frequency hopping spread spectrum technique is often implemented in wireless local area networks. The direct sequence spread spectrum (DSSS) technique. In the direct sequence spread spectrum (DSSS) technique, the signal being transmitted is divided and injected with multiple frequencies within a particular frequency band. The original data is mixed with redundant data bits or code, called chips or chipping code, and the ratio of the chips to information is called the spreading ratio. A high spreading ratio indicates a wider bandwidth. As per Shannon's theorem, the higher the bandwidth, the more immune the signal transmission is to crosstalk, interference, and noise. The DSSS technique helps maintain secure signal transmission with a high signal-to-noise ratio (SNR) at the receiving end. And the DSSS technique helps recover the original data even when a part of the transmitted data is corrupted. The DSSS method of modulation has a higher rate of transmission than the FHSS method. In terms of the signal transmission rate, DSSS is superior. However, DSSS is vulnerable to electromagnetic interference and noise produced by devices operating at the same frequency band. The differences between FHSS versus DSSS. FHSS. FHSS changes the frequency, and the hopping of frequency follows a pattern known to the sender and receiver. Lower signal transmission rate, up to 3 megabits per second. FHSS is a robust spread spectrum technique that is suitable to employ in harsh environments. FHSS is suitable for single-point as well as multi-point communications. The decoding process is simple in FHSS. FHSS is less reliable. The analog to digital conversion in FHSS takes less time. At a lower transmission rate, FHSS is cheaper. FHSS is not dependent on the distance of signal transmission. At a given transmitting power, FHSS offers higher power spectral density. As the carrier frequency is varied in FHSS, it causes frequency selective fading, where the error is bursty in nature. BSSS. BSSS changes the phase, and the carrier frequency remains in a fixed frequency band. Higher signal transmission rate, up to 11 megabits per second. BSSS is a sensitive spread spectrum technique that is influenced by harsh environmental conditions. BSSS is suitable for point-to-point communication. To decode in BSSS, a particular algorithm is required to make the connection between the transmitter and receiver. BSSS is more reliable. The time taken to convert an analog signal to digital is higher. The implementation of BSSS at radio frequencies with a high transmission rate is cheaper. Distance is an influencing factor in BSSS. At a given transmitting power, the wider operating spectrum of BSSS provides lower power spectral density. In BSSS, the message bits are both frequency and time spread BSSS. This kind of spreading reduces the influence of interference and fading. The percentage error in BSSS is less than FHSS. Understanding the differences between FHSS versus BSSS can help you choose the appropriate spread spectrum technique for any given wireless communication application. Cadence's software can help you in designing spread spectrum-based wireless communication systems.